Sorry.
Velocity was the first unit.
What did I say?
That's like
Velocity and acceleration. The normal.
the third unit.
What if I give you the velocity and ask you to find the position?
The velocity and position.
Integrate.
Yeah.
All right. So what was the question? You said
L'Hôpital's
okay.
and local extremum and absolute.
All right. So let's deal with local extrema first. So let's see. It's kind of weird to come up with a function that'll work nice. So let me just be extra cautious here. Okay. So there's two ways to find local extrema. There's two different tests to apply.
Second derivative test.
In the first one. Yeah, in the first one.
All right. So together you got both. So the first derivative test is when you draw that number line and just look to see what the slope is doing. You can kind of get a feel for what the shape of the function is. But the second derivative test is really nice when the second derivative is easy to calculate. Right? So for example, this one. So let's do it both ways real quick. Of course, to find the critical numbers, I first have to figure it. So the question would be find all local.
Absolute extreme is just the biggest.
Yeah.
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 And then what do I do with that? I look to see where it's equal to 0 or, and of course in this case that's a silly question. So how do what do I do to set this equal to 0? Take out.
Yeah.
Is this using local Yeah, this is not. Oh, we're looking for a local extreme. Oh.
Yeah.
Sorry, I took his question and reordered it. Sorry. So those are the two what?
Critical numbers.
And those are where what can happen?
Possible zeros.
X or min.
They're the definite 0 slopes there. That's definitely 0 slopes, but they're only possible maxes and mins because why does a 0 slope not have to be a max or a min?
Because it could be
A resting spot and it keeps going. I like it. So it doesn't truly turn.
This could be a stop.
All right, how we
A
doing?
stop.
It could be a, yeah, exactly. We're not stopping anywhere, kids. No, we're going to stop. Maybe it stops.
could be the economy.
Yes. It's the economy, stupid. So if I want to do the first derivative test. Alright. What is number? 0 and 4/3, and what did I highly suggest you put on this? So you guys do this in such a weird way. How undefined? 0, 0. You put a little u if it's undefined. So that breaks up your number line into 3 areas. And multiplicities help here, right?
Yeah.
But if you don't understand them, you don't have to use them. So if I put in there 1,000,000, that'd be positive times positive, right?
Yeah.
Because it doesn't matter. You just pick any number you want to in the whole area because you know it doesn't change until it hits here.
And because it's odd, it's the same and then different. So
No, since it's odd, it's going to change.
right.
So negative, positive. But if you did plug a 1 in, you get negative times positive. You did plug a negative 3 in, negative times negative. So that means it becomes positive, right? So either way, who cares? So what does the function look like?
Like this.
Goes up, it's flat. Comes down, it's flat. Goes up, yeah. Goes up, it's flat here. Goes down, it's flat there, and then it goes back up. Or if you don't like doing something like that, you just say up, flat, down, flat, up. Alright?
And then concavity would be the same test, just with second derivatives.
So real quick, let's make sure. So what's the max, local max?
That would be 0.
0, 0 what?
0.
0, 0. So you are lucky on 0. It doesn't matter which one you plug it into. What's the min? 4/3, comma.
Something.
Something.
4/3. So 4 minus 4 is 0. Wait, never mind. 36 divided by 3 is 12. 36 over
24. 4, 5, 16.
64 48.
Negative 128 over 9.
There's negative 128.9, which is negative
128 over 9. Yeah.
128 over 9?
Yeah, negative 128 over 9. I don't know how you did that.
Factor this and makes it easier to plug in.
Yeah.
Wait,
All right.
is this for a second?
How we doing? Okay. Second derivative test. You wouldn't do this. Let's do this. You wouldn't do any of this. You would, right here, you would immediately go get the what?
Second derivative.
Obviously, had to follow what the name of it is. What's the second derivative going to be?
That would
It's
be
gonna be 36 times 2, which is 12. Yeah, 72.
minus 46.
And then you just say, you plug 0 in, and if it's negative, then that means it's concave down. That would mean it would be a
Max.
and if it's positive, it's up, it would be a min. It's almost too easy. It's so nice of a test. I love this test. This one's nice too to get the whole shape, but that one's just like straight to the point. Just what's the cup look like there? Is it up, cup, or down?
So if you plug a 0 in and it's negative, then that's max.
Yes.
Which is what we got.
Yeah.
And f double prime of 4/3
should be.
it's bigger than 1, and 1 would be positive, so that's got to be positive. Min. Is that cool? Just in case I ask you to do
Secondary.
the secondary test, it's good to know.
Is that just a rule to memorize, or like why is it
What's the second derivative tell you?
concave?
Concavity. If it's concave down at a point, and that point is a critical number, then it must be a max. Cool. When is this indeterminate? When is this inconclusive, I guess is a better way to say it.
If it equals 0.
If it equals 0. If it equals 0, I don't know what's really going on there. I have to use the first derivative test, so I like it.
So, and then for concavity, you would get the critical numbers of the first derivative, right? And then you would do the...
No. So this would only tell me extrema. If I wanted to know
Concavity.
intervals of concave up and down, I would find the critical number from this.
Oh, yeah.
Yeah. And then apply a similar test. And to be honest, you could talk about third derivative test for the second. Just screw that. Let's not do that. It would sort of work. Won't work. How's that? Is that?
How would you find the absolute extreme?
Oh, absolute extreme is awesome. If I said find the absolute extremer for this on the interval
Close interval?
-4 to 1,
Then you would just...
Is that
test
what-
negative
which
4.
critical number would you not care about?
The one that doesn't fit.
The one that doesn't go in the interval I care about, right? So I wouldn't worry about this. So I just check out what's f of -4, what's f of 0, what's f of 1, and see who wins. That's why I love absolute extrema. As a student, you should love it because it's a lot less ambiguous. You just find all the points that it could happen at. Where could it happen? The critical numbers or the endpoints? Because critical numbers are where it turns, but endpoints, hey, that could be the absolute max. So that's why the endpoints are included also. You could just kind of stop at the highest point. You go, oh shit, that's a, oh shit. But that's sort of like just step back and see who wins. Who's the biggest, who's the smallest? Yeah, you won. Yeah.
So like in this case, because there's 3 numbers, let's say you get, you end up getting like a local interval, would you only like box the ones that are extreme?
Do what now?
Okay, because you know how there's, okay, so let's say like one of them is like an absolute minimum, and then there's like another one that's a local minimum.
So on this particular problem, this particular problem,
Yeah.
that I don't think that could happen. But in general, it could certainly happen. This would only find absolute. This would only find absolute. To find local, you need more tests. Because, and hopefully it makes sense, a local max or a min could be, so that's, let me see, did I set it up? No. You ready? Yeah, Jeff, we're ready. Do what you're going to do. That's a local max, right? That right there, is that a local max?
Yeah.
Where have I gone and see? And that's a local min, right?
Yeah.
Isn't that bigger than that though? So that's why local stuff needs more definitive tests. You can't just go, well, that's bigger than that one. That's all the big ones are the maxes. No, you don't know that shit. You don't know how deep it went or how high it went. But absolute max and min, that one you can just step back and see who's the biggest, who's the smallest. You're done. How we doing? Okay, cool. And then the other part of your question was L'Hopital. So what about L'Hopitals?
Indeterminate forms, what does it mean?
All right, let's try to list some indeterminate forms. And this is actually in the homework. I like this little part of the homework where you had to tell what form it was in and if it was really indeterminate or not. So what's the definitely indeterminate?
0 to the 0.
0 to infinity?
0, 0. 0 to the infinity is interesting.
1
Is
to
that-
infinity.
1 to infinity, yeah.
What about,
Infinity.
Now you
What
just bypassed all the like normal easy ones.
what about infinity to 0? Infinity to 0? 0 raised?
Yeah, well, yeah,
Zero.
0 times infinity. I like it.
0 raised to? I mean, wait. Infinity raised to 0.
Infinity raised to 0. That could be. What do you think is going to happen there, though?
Wouldn't the bottom say you're going to infinity and 0 would say you're going to 1, but that's...
So we can't say. I like it. So that's what tells you it's indeterminate. It depends on which one's going quicker. If it's going to 0 faster, it's probably going to be somewhere like 1 or something close to 1. If it's going to infinity faster, then it could be infinity. This one always freaks people out because on first glance you're like, well, 1 to infinity is 1. But again, you don't actually get to either of these things, do you?
No.
You don't actually get to 1. You don't actually get to infinity. All right, no one's gotten there yet. There's a group trying. And what really, it doesn't, it's a little bit of a pet peeve, but for some teachers it's a little bit worse. You never say like the limit of x to 0, let's say infinity, 1 over x. No, that hurts me to see that. You cannot plug infinity into something. You cannot. Because you can't even get it. I can plug 2 into something. There's 2, look, there's 2, I can put it in. Where's infinity? It's over there. It's an infinite long distance away. I go 1,000,000 miles, how far? It's the same distance. Well, screw you. But that's the right answer, right? That's what's weird. Walk an infinite distance. Where's infinity? It's still an infinite distance away from you. What? Okay.
Okay, so if I had something like infinity to 0, how would I rewrite that?
Oh yeah. All right. So let's see. Oh, that would be something like. Let's just do the simplest one.
Yeah.
Right?
Yeah.
Oh shit. That sounds like something I would do to people.
Well, so you have to El Hospital. Just kidding.
Why won't L'Hopital? What does L'Hopitals require? Which is not true about most of these forms, is it? There's only 2 forms up here that L'Hopitals can handle directly.
It requires division.
Yeah, you have to.
These it can handle directly.
Yeah.
All the other ones I have to. Yeah. So watch this. If I just said x times 1 over x plus 1, and that's a silly example, but
That's x over x plus 1.
I'm sorry, x times 1 over x or something, right? And letting it go to infinity. That would be infinity times. Oh, I'm making too big of a deal. I'm sorry. This would be infinity times 0, right?
Yeah.
But you can rewrite this to be, now this is going to be weird, but I can rewrite this to be like that. I mean, it's kind of silly because it just goes to 1.
Yeah.
I'm just trying to give a quick example. So if it's like this, you can invert one of them. If it's 0, if you invert it, it's infinity, so then it would be in this form. So you can rewrite the other ones to be ratios. L'Hopitals only works with ratios. That's how it's built, right? The ratio of 2 functions, the limit as x goes to something, is the ratio of their speeds to that thing. That's the only thing it works on, right? So I can't just take this guy's derivative and hope something happens. That's not how it works. So who remembers what to do? These stupid powers with variables in them screw us over, but there's a general attempt, a general way to try to do it. Because what works with powers? What makes... Huh?
Logs.
Yeah, exactly. So you say that. Stop there for a second. You with me so far? So then the limit, let's go to infinity of this, would be the limit. So whatever I get as an answer, what do I have to do at the very end?
You eat it.
Eat it. I like it. That's exactly how I'd say it. Verb the words. In this case, we're verbing a letter. I like it. Audacious. All right. Come right. So this is still a product, isn't it?
Yeah,
So not still, but it is now a
Zero
product.
times
It's still not good. So how do I convert this into what I need it to be? It's almost silly.
So it's 1 over ln of x?
Well, it's even better just multiply.
Yeah,
Oh,
ln x.
okay. Fine. Sure.
So now, as x goes to infinity, this is going to what?
Infinity.
This is going to
Infinity.
This says so, right?
Infinity.
This is how you write the form it's in. You put in parentheses, so you say, I'm not saying it equals this, because that's crazy, Jeff. I understand that. I'm saying this is the form it's in, and that's completely allowed. So now what can you do?
So it's 1
Now you
over
can
x over 1.
Well, finally, we got it in the freaking form. Look, that's all it requires. It's like, geez, dude.
1 over x over 1.
1 over x over 1. Which is?
Which is 1 over x.
Which is?
Which is 1 over infinity.
No, what's
which
1
is
over
0.
infinity? What's 1 over really big?
0.
One semester I had my student, everybody was freaking putting infinity, so I said put BFN. Big freaking number. Right? I'm like, that's better than putting freaking infinity. You cannot put infinity in something. But that, of course, goes to 0. And it's because, I don't know if you picked up on this, and you'll definitely pick up more on this if you take 280. Natural log is the slowest growing function. It's just so slow.
Yeah.
It's unbelievably slow. It grows slower than this in a way. I mean, it's crazy. You'll see, if you take 280, you'll see what I mean when you get to sequences. So what does that mean? That's on the top. Well, are we done, though? I got to be careful.
So is that
I want to talk a little bit right now, but we're not done.
No.
We have to eat
We got
it.
to eat it.
So we have to eat
But real quick, if that's really slow growing, then that must be going to infinity faster. So since the bottom's getting big faster, the whole thing goes to 0. That makes sense. Now the answer is going to be,
E to 0, which is 1.
yeah. So the limit of this is 1. I like it.
Bang.
I like it a lot.
I gotta read it.
So when you put an ln next to something that's going to infinity, are you being mean to infinity?
It's hard to be mean to infinity. To infinity, we are way back in the dust. It doesn't even know we exist. So, I like that. Being mean to infinity.
It's like putting a parachute on. It's like you're slowing the roll.
Oh, you can't slow it down. Well, yes, you can. You can go to infinity very slowly. Yes?
Can we go over the fight?
On the test. The one with the x equal y cubed stuff? Okay. So everybody had the same idea of a problem for number 5. You just all had slightly different coefficients. So you all had a function based on y. The key thing there was in the first quadrant. I need the region to be in the first quadrant. So some of you guys didn't see that or something. Now, if this is all x stuff, it would look like what? What would the end behavior be? What's the end behavior? Replace all the x's and y's and make it into a normal function. When the end behavior would be, normally a cubic is like this, but this is negative cubic, so it should be like that. So it would look something like this.
What if it's y?
I know. So now it would be inverted for y. So it's going to look something like this. I just got to find these points, which is doing what with the function?
Equals 0.
Setting equals 0.
It tells you what not to use.
Exactly.
Yeah.
I didn't want to just say don't use. I wanted to make it a little bit of work for you, but I wanted to make it so that I'm telling you what to use.
Yeah, that was my problem. I tried to do that.
So you just got to find these y-intercepts. That's all you got to do is find the y-intercepts. This one doesn't matter because it's not in the first quadrant. So you end up with this kind of a shape. Yeah. So everybody's looked basically like that. By the way,
Is it okay if I just label the x-axis y and the y-axis x because I find it a lot easier to think about it like that?
The reason I don't want you to is because just in case you're going to 281, even if you're not, I almost don't care. You got to get used to looking at everything you know about x, you now know it about y. So there were a couple of people that turned this into a function of x, which in one way I think is smart, but in a second way, you're not getting the practice you need for when you're not able to do that. So when you get to 281, you're going to have functions of y as a function of x and z, and so you got to get used to thinking in different directions.
It's very difficult.
I know. Yes, ma'am.
Okay.
Wait, time? Yeah, okay. So for the left endpoint, right endpoint, or whatever we use
Yes.
for the approximations, I'm still, I'm trying to get, why it wouldn't matter.
Oh,
which
all right.
method we use.
So real quick, everybody's function looks something like this, and almost look normal. Right? And see, I say almost for a few reasons. But if I drew in, so some of you guys went from -2 to 2, some of you guys went from -3 to 3, whatever. So if I drew in these endpoints, I have to be sort of raw. I screw it. Just get to the chase. Right? You with me so far, Angela? So I actually use 5 rectangles, but I don't care. I'm just going to do this for a quick visual. See how this is over a bit, but this is under a bit?
Yeah.
So if I did it again, wouldn't it just be the same thing, just turned around?
Yes.
You with me?
Okay, so the area really wouldn't change?
Yeah. Left or right endpoint, since it's symmetric, the overage would just be on the other side now. So it doesn't matter which one you use. Yes?
This is number 6, right?
Number 6.
One thing I was thinking about was the midpoints.
Yeah.
In relation to midpoints.
So, let's see. I need one more color.
Is midpoint in between the left and right, or?
Yeah, midpoint would be like right there. So what I would do is, let's say you had from -3 to 3.
But wouldn't that be a little bit weirder to get in between, because
Real quick, watch. So those of you who had this, your width was what? What was your width? Yes. Cool. So then the first thing you should do is figure out what all the points are, and then you figure out which ones you want to use. So you go by 1.2 basically, right? -1.8, 0.6, -0.6, got it. 1.8 and then 3. So if you want to use right endpoints, you would use these. Left endpoints, you use these. Stop. But if I want to use midpoints, I'd use the one in between there, the one in between there, the one in between there. Right? Which in this case, and midpoints are normally the nicest because they infuse, the process for midpoints infuses the idea of averaging the left and right endpoints inside because it's the freaking average of the points. But here, you can see how it's not nice very often. It's not hard to figure out what the midpoint is of these, right? Is it? What would the midpoint be? 2.4, and then you just go 1.2, 1.2, because the midpoints will be the same distance apart as everything else. If you get that, it'll come out to be the same answer. Because the left and right are the same, so the average would be the same. Holy shit. So what's up? So on the picture,
point be different because of a different slope?
yeah, so it's not perfect. You're right.
Because that's what I was confused about when I was looking at it. Because I was like, that's where I kind of got stuck on. I didn't.
So it's not perfect, but it's close enough for the most part. Yeah, because you can imagine if this was really like that, and the midpoint would be closer to this. Yeah, so it's not perfect. Yeah. Yes. So you could have said something like that, but still, it's midpoint's normally used to be roughly the same as left and right endpoint
Yeah.
averaging. And depending on exactly what the function looks like, one is better than the other one, but there's no definite winner. So we just sort of say they're about the same.
That was also one of those things that like really kind of threw me off because it was obviously about the being symmetrical. So it was like, but these like they'll be the same year, but they won't match up with these because they could only get that stuff. It's not like you're using 5 points all the same. It's half of those points in those things.
Okay. Yeah.
It's easier to kind of show, but yeah.
No, I know what you're saying.
Yeah.
That's fine. Right?
3A.
Which one?
3A.
3A? The one about finding the curves meet? So, yeah. Set them equal to each other? It's a grouping problem just like we had on the practice one. You see what I mean? Set them equal to each other, subtract one part over C to be equal to 0.
I mean, I found it.
Oh, yeah, you didn't factor it all. If that's the way it is, then it doesn't factor it. No, but you can't do that if that's not the same as this. You could even collect those. If they're not the same, you can't do the next time. Yeah.
Number
I can see what you're trying to do.
What
but
D
it
was,
doesn't work.
it was impossible, right? Because
For what we're
you
trying to
cannot
do.
integrate dimensional
Yeah,
logic.
if you wanted to do
No, it's totally possible. Yeah, I remember your comment. You're forgetting that there's an over U in there. So what you did was fine. You got to this point, right? But what if you let M, because you already got U, if you let M be natural log of U, what's dm? What's the derivative of ln?
Yeah.
That's double use.
But you didn't have to. What you did, you could. You didn't have to do double substitution.
So how do
You could let U equal ln
Oh,
from the beginning. Yeah.
And then when you factor out the 4, then you'll get.
So I agree with you. If it was ln by itself, you couldn't. But it's not ln by itself. There's another piece in there that saves it. Whoa. It is Thursday, so gotta keep an eye on the clock. Goes away.
Oh man.
Because those are your bounds, which is easy to cross.
Well, yeah.
So you had to draw your crosses down here, because that's where your bound ends. And then you get that.
Yeah, my 2a was ln x plus 2 over x plus 2.
Remember,
Oh, no, 2a.
interval V, whatever your parallel.
Find my radius.
Yeah, it's 2a.
So washes would be GX. Shells would have to be what? Yeah. So you need to use washers. For part C, you can use shells. So for part C, what you're doing is right. So what you're doing is actually answering part C. Huh? Yeah. Does that make sense? So remember, washers are always D, whatever the axis is, or whatever is parallel. So shells are the opposite.
Are we looking for area between curves?
I'm so interested in one area. I know like the area is like
No. That's when I rotate. Pi comes out because I'm rotating and I'm making a circle. So
you said no rotation.
Yeah,
Yeah, there's no rotation, no rotation. I just want to find the area between those curves.
So just,
So help me out, Angela. How do you find the area? How would you find the area under here from A to B? You would just do what? How do you find the area? Just integrate, right? Integrate.
okay.
So how would you find the area under G of X here?
Do you add it
How would you find the integral under G of X? You would integrate.
from A to B?
So how do you find the area between the two? You would subtract them, right?
Okay.
Wait, so I'm supposed to find the area of both?
No. So what you do is you just set up the integral f of x minus g of x.
Plus 75 by g, and then you integrate from there.
Well,
But you don't, there's no pi, you're not rotating. Pi comes because of a rotation, of course, and you make this circular motion. That's where the pi kind of comes from. We're not rotating this, we're not finding volume.
so the whole thing would have been sorry.
You just gotta be careful about which one's on top.
So the top one was this one.
Okay, good. So that minus that,
And just integrate that from.
yeah, wherever it goes.
So you didn't mark these numbers, so these are correct, right? I just add them up wrong?
I don't know. Well, to be honest, I didn't have time to figure out which one was wrong because you were right up to here, but then something went wrong here. I just didn't have time to really pick out which one.
Multiply these out.
What was most important to me is you were right. This is right.
Yeah.
Something went wrong here. I just didn't have time to figure out.
Their projector.
I didn't show my work, so right here, the 3B. Well, 3, but,
Oh, no. The word for finding this.
It's should have been like an easy.
What is it? So you get more answers. No. There's no one.
even my hair, like,
I just was like, which
I don't know. Because that's what I ended up doing. Like, you don't have to. So I ended up putting 2 and then doing from 0 to 2, and that's why I only do the.
I can give you some points back to part A because you actually got that.
Okay. But, Wow. I mean, I shouldn't do the symmetry thing because it changes the.
Oh, yeah.
But then it changes the
You can't do double in area if it's not symmetric.
Okay.
Yeah. And for volumes, you have to be symmetric to the axis you're rotating around.
Do I have to rewrite all this stuff too? Or do I just rewrite all the stuff that I did?
Just because that's where you first, you don't have to, you could, I'm not going to let you, but you don't have to. You've got all this right. Your mistake was in the video, right? Oh, you didn't swear it, that's all? Okay. All right.
Yeah, it's the opposite. Oops.